many other people will still join us. As we are continuing, I am going to call upon a researcher. He is a researcher with robotics. He has done one or two works with robots to read the citation of our speaker. His name is Engineer Onyekachi Oloto. To read the citation of Dr. Ekene Samuel Mbono. Thank you so much.
Thank you so much, Dr. Leka, and good morning, everyone.
Good morning.
Good morning. Thank you. Mbono Ekene Samuel is a control system expert and a research and development consultant. He had his bachelor in engineering in electronics and computer engineering from Nnamdi Azikiwe University, Nigeria in 2005. Master in engineering, in computer engineering in 2012, and PhD in computer and control engineering in 2017. He's presently a senior lecturer in the Department of Mechatronics, FUTO. He was the head of Mechatronics Department and also head an R&D department at Electronic Development Institute. That's the formerly Center for Adaptation of Technology, CAT, OCA, under National Agency for Science and Engineering Infrastructure. That's where he worked as a senior research and development engineer from 2007 to 2014. In 2009, he served with the mechatronics team that automated cassava flour mill at Scientific Equipment Development Institute, SEDI, Minna, Nigeria. In 2012, he was a resource person at IEE workshop on robotics in Abuja, Nigeria. In 2014, he served with the military research test team that repaired the surveillance system of 930 military aircraft belonging to Nigerian Air Force at Air Force headquarters, Benin, in Edo State, Nigeria. In 2014, also he received award from IEE USA as a resource person on symposium on special topics from industries at Federal Universities of Technology, Owerri, FUTO, Nigeria. Ekene worked at Shell Nigeria Exploration and Production Company, SNEPCO, that's Lagos, Nigeria, in 2015 as a PhD research intern on control system security. He has also worked in different areas of embedded and computer system design, such as remote application-based system, artificial intelligence system, wireless sensor applications, computer interface with embedded system, modeling simulations of real-time systems. He has a persistent automation and associated softwares and hardware. His areas of interest include industrial control system, automation and associated softwares and hardwares, network design and cloud management, embedded systems, WSN technologies, remote monitoring and reporting, and project management. He has more than 30 technical publications and has presented papers in both international and local conferences. Professionally, he is a member of NSE, IEEE, and HORE. Thank you so much.
Thank you, Engineer Onyekachi Oloto, for this citation. Without making much ado, we invite our distinguished speaker for today's event, that is Dr. Ekene Samuel Mbono. You have the floor, sir.
Okay. Um, Thank you very much, Chair, and everyone in the house. I want to thank the person that read my citation. We give God all the glory for those achievements. And I want to welcome every one of us to this event. It's going to be a discussion having spent more than 20 years of my life in engineering. Uh, there are things to learn, there are adjustments to make, and particularly for our country, Nigeria, we really need to make impact. So I'll be sharing my screen again uh, so that we can get into the business of the day quickly. Please confirm you can see my screen on presentation mode.
Yes, we can see it, sir.
Yes, I can see it.
Okay, so we're looking at building a career in robotics. Just a quick guide, building a career in robotics, a quick guide, particularly for students who may want to have a career along this line. We'll be looking at definition of terms, and then after defining some basic terms, we now begin to look at the lecture proper. After that, we look at career opportunities for robotic engineers. Then I will like us to take note of some of our recent activities, RISE activities at Photo. Incidentally, I am the RISE Photo advisor. And then there is this area, every one of us, especially the younger ones that are coming up, you need to look into the area of additive manufacturing because it has the potential to make robotics to move forward, especially in developing countries. Now, to build means to develop capacity. I'm speaking with the respect to the context of discussion this morning. When we say we want to build, what we mean is that we want to develop capacity in the area of robotics. And drawing from the book of wisdom, I mean the book of Proverbs, to build takes patience. It tells us that should be Proverbs either chapter 8 or chapter 9. It tells us that wisdom builds her house. She has put out her 7 pillars. So, one of the challenges we have in this part of the world, and also what I have discovered in my interaction with people over the years, is that not everybody, just very few people, have the patience to sit down and build. Most people want already made stuff. This part at this phase of my life,
I did be more, sir.
having any, any issue.
The market women.
Oh, please, if you are not speaking, mute yourself. Mute yourself, please, so that we have one house. Thank you very much. At this phase of my life, I have dedicated my life to building younger people by the special grace of God. So that the picture you are seeing on the screen are just very few of our activities trying to develop capacity in the area of robotics, the area of embedded system, the area of automation. Of course, we can't talk about robotics without talking about embedded system, without talking about automation. As we are going to see, all of those things are infused into robotics. It's not one field. So we get to develop capacity. That's what it means to build. And what we are building, yes, we can build technology, but we get to build human beings first. We get to build human beings first. Let's go to the next slide. What is career? A career is the long-term pursuit of professional growth in a chosen field or industry. Somebody like me, I have taken engineering. By God's grace. I'm almost getting to the peak of my career. So sooner or later, that will happen. I've already built career and developed capacity along this line. So it spans your working life. This is something you give yourself to. It's not, that is, you have given, that is, when you look back, when I look back 20 years ago, when I started learning electronics, programming, it is a cumulative something. Today, when I look at the wealth of knowledge that have been accumulated in the area of engineering, it is quite enormous. So it spans your working life, often involving a sequence of related jobs, continuous skill building, progression from entry level to advanced or leadership roles. I want you to confirm that you can still hear me.
Can hear you, Doc.
Okay.
Yes, Doc, I can hear you.
Okay. Thank you very much. What is robotics? Robotics is an interdisciplinary field combining computer science, artificial intelligence, and engineering. What we mean by engineering here is not just one area of engineering. As we are going to see, it's all encompassing. So these fields come together to design, build, and operate programmable machines. Principally, these systems use sensors to perceive their environment, microcomputers to process data, and motors to actuate tasks, ultimately designed to assist humans and automate complex processes. It's a vast field. The key components of robotics, when we talk about the key components of robotics, we are talking about sensors, which function as robot eyes and ears and other things. Just think about 5 sense organs in human body. You have the nose, that's sense of smell, sense of touch. You have a taste, which is the tongue, have your eyes, and other ones. All of those things are emulated in robotics. Then you have your brain, which processes information. That's where microcontrollers and microcomputers come in. Then you have your actuators, which help you to help the robot to move around. Okay, and several things are coming off both in biomedical engineering. What is this field again? the people that deal with bones. Several things are coming up. Okay? Artificial limbs. I mean, robotics is actually making waves now. So, having said, defined some terms, let's look at the roadmap. Let's assume that somebody wants to develop a career in robotics. Number one, you have to choose the right educational path. You have to choose the right educational path. In the area of mechatronics engineering, among all of them, mechatronics stands out in the sense that mechatronics is combination of almost every other one. And mechatronics engineering, not because I'm mechatronics engineering, but we are talking about reality. In our department, for example, we have people from electronics, we have people from electrical, we have people from mechanical, we have people from MME, material metallurgical engineering. So, and when you come there, you can't do electronics without computer engineering. There is computer expert. As a matter of fact, we have three major options. We have control. We have control option. We have software option. Then we have robotics option. All these things, you look at it, they are interrelated. You can't really do mechatronics without a mechanical person being there, or without somebody that will tell you about materials. Later we are going to talk about additive manufacturing. Because if you are going to manufacture a robot, you must take into consideration the material selection. You can't build a robot without artificial intelligence. So why people in different field, aspect of engineering, why they form part of robotics? Mechatronics that is, to the best of my knowledge, is the central course for undergraduate level before you begin to specialize. Mechatronics will give you advantage, just like we have in Futo now. The mechatronics students, they always have advantage in the sense that they are taught from lecturers from different backgrounds. In fact, after producing them, we notice that each student becomes better than every lecturer, because you are just one person, but all of us come together to produce the students. So at the end of the day, you see you have the students doing stuff in additive manufacturing. You see them doing programming with Fusion 360. You see them doing embedded system. See them doing all kinds of things. At times we wonder, where did they learn all these things? They pick them from every one of us. So at the end of the day, they are better than every one of us. Important subjects to master. Anyone that doesn't like mathematics shouldn't get into robotics. You hate physics, you won't do well here. You don't like programming, then don't come into robotics. You must understand control, because robotics has everything to do with control. And then the person needs to understand circuit design. Talking about circuit design, this one is not part of this slide, but I need to say this. When it comes to learning stuff, circuit design, basic electronics, there are 5 things you need to master. How many things did I say? How many?
5 things.
5. There are 5 basic components, 5 basic components the person will need to learn from the scratch. I mean, you have to learn them in depth. Number 1, the person must understand what is resistor and how to use resistor and apply resistor. You see this thing called diode, the person must be grounded in it and how to use them. Not just some of these same people do read one thing or the other, and within 2 days they say they have known that thing. No, you have to study diodes in details. Another thing is transistor, BJT. Then after transistor, you capacitor. When you get into capacitor and you really want to study capacitor, you notice that for 6 months, I'm not finished studying capacitor, if the person must do the right thing. And then finally, inductor. If as a student, you can ground yourself in this area, then there is nothing you won't be able to understand, because when you now begin to talk about MOSFET, you notice that MOSFET is an upgrade of transistors. Talk about transformer fundamentals tells you about an inductor, application of an inductor. All kinds of things. When you now begin to talk about ICs, integrated circuits, you notice that you are revolving within these things. You get into gates, you are revolving the same thing, because that is a basic building block. You notice you can use diode to form AND gate, OR gate, NAND gate, all those things. So these things have to be studied in details before we jump into programming. It is disturbing. Even though it's good, but it's actually disturbing that some of our students don't want to spend time to learn hardware. I don't know. Some people think that a time will come, software will take over hardware. It's not going to happen, because there is no amount of development that will take over hardware. It's just like saying that a time will come, you are going to depend on, you just drink water, you see a human being that doesn't have a physical body. No matter the the level of intelligence and the sophistication, or complexity that we are having from software, developing software, it can never take the place of hardware. Every robot must have a physical body. When we're talking about, say, humanoid robots, you can't take away the physical. Even in IoT, we are talking about here and there. IoT starts from the physical layer. So IoT cannot hang at the level of the cloud. You must have a physical layer where you pick data from the physical environment before you begin to transmit. So circuit design is a very key component in robotic development. We move. Now, when that person has grounded himself in the hard way, at least have developed a level of mastery in the hard way, you now come to programming skills. You are going to program some of the things. Of course, if you don't understand how LED, light emitting diode, functions, you notice you may not know how to program LED. You may not know how to switch LED with your microcontroller program. If you don't understand how servo motor works, you can't drive it. If you don't understand how stepper motor works, you can't drive it. Somebody can copy somebody's program. That's correct. It's allowed. You improve on it. But if any problem comes up, you notice that person doesn't have fundamentals of how that thing works. The person will run into a problem. He can't change it. So recommended languages. I may say something that will shock you. The first language should actually be what? Based on what is on the screen. Yes, I need somebody to The first language there is what?
Assembling language.
Assembly language. You see, many people may want to argue about this, but I've done my research. I actually started from assembly language. When we come down to here, when we come down to this part of the world, we tend to downplay assembly language. We say it's old, it's outdated. It's not true. After this lecture, I want you to do a search. Check all the universities abroad. Find out whether they still teach their students assembly language. If that is the case, if even you go to countries like US, Japan, China that have developed, they still teach their students fundamental language, which is assembly language, the machine language. If they still do that, then there is wisdom in that. And it's very simple. You can't speak a language comfortable without learning the alphabets. That's what assembly language is like in programming. Because especially for people that are going to work with hardwares, you get to understand how things work. You need to understand what is bit, what is a byte. You need to really understand what is interrupt from the basic understanding. You need to, when we say memory locations, you need to understand what all those things mean. The architecture of a computer, of a microcontroller, we say data pointer, all these things, you are not likely to understand them from high-level language, and the reason is very simple. At the level of high-level language, some people that felt, or some people have made, let me put it this way, they have made life easier for us by developing what we call libraries. So you import this one, you import that one, you include it in your code, and it's working fine. The problem is that if you run into any challenge with that code, you won't be able to resolve it. And also, the world is competitive. Any day I notice that you are using, let's assume I'm at the forefront and you are following me behind, and any day I notice you want to overtake me, and it's my library you are using, you are importing. What do you think I will do? Yes. What do you think I will do to have advantage over you? Nobody's responding.
I will simply upgrade.
Some people will try to eliminate the other.
Eliminating the other, how? Please feel free to talk. This is an interactive section.
I said I will simply upgrade. Since you are copying me, I will upgrade to the higher version.
Okay, that's part of it. That's part of it. I will upgrade to higher version. Any other suggestion? Now, look at it this way. I am the one that developed the library you are using, right? And you don't have idea of the assembly language that controls the library. We really need to, some of this library we import, you need to go to the background and see what is going on. If I go there and change a bit, just go to the what we call the H file, and change the configuration there, you are gone. I change it and upload it, and then tell you are going to do updates. You do updates, your system will stop working, and you can't fix it. You can't fix it because you don't have the working knowledge of how that thing works. I have last year, I had a training with a company at Abuja, and then we were to develop something, a code, a security stuff for them. And we were to work with ESP-C3, and they develop something that works with GPS, global positioning system. So when I got there, the library they were using wasn't working. I said, okay. What I did was, because I had, by God's grace, an understanding of assembly language code, zeros and ones that control that thing. I said, leave that library. Fundamentally, this is how GPS system work. So we went back to the assembly code and solved that problem. If not that one is knowledgeable in that area, that would have been that would have taken us a long time to solve, because import this one, do this one, do this one. At the end of the day, there are conflicts of program here and there, and somebody gets stuck. So assembly language is very key. We need to go back to it before we now begin to upgrade embedded C, which is largely what you see in Arduino, and then Python. You now begin to come up Python, which helps you in deploying AI, machine learning, automation. All these things are very good. You can, what I'm saying is that we can't leave one and downplay on the other. Otherwise, we will just be hanging, especially in this our country. We'll just be hanging. You see, we talk a lot about these things, but when it comes to physical implementation of products, you notice that we are not there. And then you now come to MATLAB, simulation and control system, which is purely for analysis. We get to analyze stuff and do the thing before we begin to implement. And then JavaScript is there. The robot operating system, you see, that is when this thing, when we begin to build these blocks, at the end of the day, we are forming a whole system. Programming skills, we have robot operating system, Arduino is there, ESP32 is there, and these things they are coming out in versions almost on quarterly basis. Raspberry Pi is there. You can see what is on the screen. These are the things one can develop, but you don't develop them in a day. I started with assembly language. In fact, not even with assembly language. I started learning components after about a year or two. I was introduced to programming, assembly language, from assembly language to C, from C to C++, and like that. I'm not programming in all the languages, but I partner with people. You can't be jack of all trades. So we just need to know the areas. But if you left to me, every person that wants to do something with robotics should at least know assembly language. So that is fundamental. You build from that. Learn robotic software and simulation. I think we have said this. You learn the way some of these things works and simulator, so that it will reduce our design time. You don't necessarily need to buy all the components to learn this thing. Subscribe to the necessary softwares, and you learn it. If you're in the university, I don't know about other universities, but there are some universities we have MATLAB license given to us by NUC. So in our university, once you have the university email address, you automatically have access to MATLAB and Simulink. And MATLAB has 112 toolboxes you can use in almost every aspect of engineering, telecommunication, 5G, 4G, all kinds of things that are there. Okay. And then after learning a while with simulators, I keep on saying it, there's no amount of simulation that will be equal to practical experience, hands-on. No. You must handle some things somebody might be doing simulation, connecting wire. By the time the person goes to the lab and you give the person wire to connect, the person will notice that can't even identify the anode of an LED. He's seeing capacitor. He doesn't know which one is positive of the capacitor and negative of the capacitor. But the person has been connecting capacitor with a software. So you notice that it's not complete. So hands-on, somebody can start with a line following robot, get to obstacle avoiding robot. These are the things we can buy from the market. And at most times, even their manuals come with them. Bluetooth control robot, smart home automation system, just to have a visual, at least a visual representation of what the future we are looking at. And then you can go on to advanced projects like drone systems, industrial robotic arms, autonomous vehicles, AI-powered robots. This is when the fundamental foundation or foundations have been laid. And then you get to document your work so that people will know what you are doing. Later, I will drop my YouTube channel. There are some things you might want to learn there, how to go about design and embedded system and other things. So you share with the community. GitHub is there, and have your personal YouTube channel. Thank God for internet. Then have your technical report. Go for conferences. Have your report. Let people know what you are doing. And LinkedIn is there so that people can contact you and can also contact people and know what they're doing. And then a course on artificial intelligence and machine learning is also recommended. Computer vision is part of robotics. Neural networks is part of robotics. Things are coming up. The day before yesterday, I did a project with biomedical engineering students, master students, call it EEG, something that can sense, predict seizure for what is epileptic patients. There are things that are coming up, that are crazy things. Now today you have sensors, that can determine the signals going on in your brain. You just place it at your forehead. The thing is bringing out your meditation level, your attention level, your concentration level. And with those signals coming up, if you put the merge it with artificial intelligence, a number of things can come up. So reinforcement learning, sensor fusion, when we talk about sensor fusion, we're talking about using multiple sensors to make prediction, and then NLP, natural language processing. You can check out, especially for younger ones. Some of us, we have defined our path already. These younger ones, you have more time, nothing is bothering your mind. You can explore this thing, TensorFlow, PyTorch, OpenCV. These are the things. Do lay hands on this thing and find out what they are. Then develop electronics and hardware skills. The person needs to develop electronics and hardware skills. This one should have come first. You develop these skills. If you don't have them, you have to develop them. Few these things. No, there are more than 1,000 sensors in the world. More than 1,000. You have different kinds of actuators, different kinds of microcontrollers. The PCB technology is also there, because at the end of the day, all these things get to be mounted on a circuit board. Okay? And then common platform, we have Arduino platform, ESP, STM32, and Raspberry Pi and others. The common one to start with is, and I will recommend people starting with Arduino, because apart from the fact that it's open source, it gives you that flexibility to manipulate some things, and at least it's very close to, the programming is very close to assembly language, it's closer to assembly language compared to Raspberry Pi. that uses something like Python and the rest of them. And then stay updated, have to go for conferences, attend seminars like the workshop or webinar like this, take online courses, read journals, useful learning platform, Coursera, edX, ME, IEEE, and stay connected with the whole communities, know what others are doing, and then most importantly, all of great importance is you have to study under people who are in the future you want to experience. Within we call it, if it's within the religious and cultural circle, we call it discipleship. With respect to what was this was a mentorship. You see, when you work with somebody who is already in the future you want to achieve, it shortens your journey. Some of our IT students working with us, we started a design on RFID based system. These are 400 level students that they've not really worked much into practical systems. So they were having challenges. By the time I came in, few things, they were struggling with the codes. Few things, do this, do this, do this, do this. Then within 2 days, they were able to build RFID based system. When I got home, I was just talking to myself. I said, this is imagine what mentorship and working with somebody that already has experience can do. It shortens their journey. If they had decided to do that thing by themselves, one thing could keep them for months. But they work with experienced person and then do this, because it is the road I have passed before. In fact, there was something that we are doing, it wasn't giving results. I said, check those wires. Check those wires. Are you sure? Even though they didn't continue it, are you sure they are okay? At a point, I say, remove all those wires, get new wires and replace. And when they did it, something started working. And they were able to see that at times, your design might be correct. Your program might be correct. It might just be one single wire in the circuit giving you trouble. And if you don't have that experience, you will stay there. But because they work with somebody that has passed through that road, it shortens their journey. It applies in every field. There are things you may spend 20 days reading a book. One man will show up and summarize what you have read for 20 days in one sentence for you. That person will be talking from the point of knowing, not from the point of head knowledge. We just tell you, do this. So all your 20-day reading will just be summarized in one sentence by one person. So internship is very important, industrial training, and if you want to do this kind of thing, find out, make sure the person is not just a theoretical person. No, let it not be that you want to attach yourself for internship. You now go where they are still talking theories. You have to be sure that the person taking you along this line is in the experience of what he or she is talking to you, telling you, not theoretical knowledge, because there are two different things. Yes, theory is good, but the person has to be in the experience of what he's trying to communicate to you. That's when these things make sense. Okay, you get into robotic competitions, IEEE robotic challenges, and all those things so that be able to appreciate what others are doing. For engineers that want to work in robotic industry, can work in manufacturing industry, healthcare, agriculture, aerospace, automotive industry, defense and security, smart system and IoT, And the common job roles, we have robotic engineer, automation engineer, AI engineer, embedded system engineer, control system engineer. The list is not, this is not an exhaustive list, but at least this is, you can start with this one, research scientist, and you can also find out some of them online. Okay. Now, I want us to appreciate what we are talking about. Let's, this is some of the things we have been doing at Futo. In fact, we just concluded 2-week intensive training in collaboration with RAS on embedded system design. So it was very, very massive, and students attended. Now, recently we automated a lift. I will just play the video. We automated a lift at Anambra State, precisely Ngozika Estate, phase 2. I hope this thing will open. Okay. It's still with these systems. Just watch the video. I am this person. This is my colleague that worked with me. He's into welding, professional welding. So he understands the mechanical system. That is the control. You can see the Arduino Uno there. This lift is installed in somebody's house. It's not, we are not talking theory now. We are talking about field work now. So he has just called up the lift. So these are not rocket sciences that we cannot do. These are simple sensors, actuators.
Stay there now until. Oh yeah, give it command. Command this now.
So that's that. This everything was done here. We just installed it, and then later they will now do the body work and package it, cover it with what they should cover it with. But then the system has been tested, automated, and is working. This one is okay. This is the just to let you see this. What is this one? This is the lift you saw now. This is the software. This is the software that controls it. So you can see it's developed, or it was developed, depending on how you want to put it, purely with Arduino. You can see the limit sensors, the alarm. You can see the limit sensor, upper limit sensor, lower limit sensor, cabin light, alarm, low and high. These are the things we can actually do. Instead of running away, everybody wants to run away from Nigeria. We can actually sit down and solve our problem. Look at this one. Look at this one. Let me open this one. Okay. Let me open this one. So, this is part of what we are doing at Photo. We build capacity, train people, solve our problem locally. Solve our problem locally. And when we solve our problem locally, definitely, we're not going to lack money. Because when we solve the problem, the national result of what will happen as you are solving the problem is a value you are creating in response or in exchange of the services or value you are creating. You will have money returned to you. That's RAS. That's we conducted training on embedded system for our 100-level mechatronics engineering students. So as of today, all our 100-level students at Futo, they are very familiar with programming embedded system. So that's that. I think having, of course, one thing I need to, before I hand over this thing, you see, we don't practice robotics by theory alone. I expect that everybody, as part of career development, you need to have a personal lab. You can see I'm talking to you from my private laboratory. This is function generator. You can see this. Can you see this now?
Yes, sir. Yes, sir. Yes, I can see it.
Because engineering is not
Yes, sir.
something you talk alone. Somebody will need to have a function generator that you get to do experiments, series of experiments. It's not just about buying a kit, robotic kit, and that is already assembled or programmed there. And then we get it here, get the manual, and connect them. They tell us what to press so that the robot will begin to move. And then we press it, it begins to move. We craft for ourselves. That thing is good, provided it will lead to reverse engineering. What I mean by reverse engineering is that we study it and then try to reproduce it. But in studying it, we need to have necessary equipment. You need to have, these things are not too much to buy. They are not really costing that much. This is oscilloscope. Somebody that wants to do meaningful with robotics, you need at least, you need to have at least an oscilloscope. Or okay, multimeter, good multimeter. You need to have a good multimeter. And then your soldering station has to be there. Your soldering station. This is a soldering station. Electronics and embedded system are so wonderful in the sense that you can practice them in your room, in your house. And then you need to have some keys. You may want to experiment on some things. Recently, we tell our students you need to buy keys. These are Arduino keys. You experiment with these and some other things and like that. So that after the theoretical thing, the person goes back to, study what has been said. And finally, we need to develop capacity in the area of additive manufacturing. You see what is happening? In fact, most robotic kits now are imported, which is a good one. We are not against it. But we need to move to a level higher. Additive manufacturing will help us to, those robotic parts, we can actually produce them with 3D printers. We can produce this thing. I encourage young ones, get into that, learn what G code is, learn how to control printers and develop this thing. Let's move to reverse engineering so that we can reproduce these things and make them available, at least reproduce the past and use it to do something for ourselves. I will stop here. Success in robotics requires strong technical knowledge, creativity, problem-solving ability, continuous practice, team collaboration. We must not start big, start small. Build consistently and focus on practical experiments or experience. Thank you very much for your time. I will stop here. Chair, over to you.
Wow. Thank you so much, Dr. E.S. Mbono. Thanks for opening our eyes to be intentional when it comes to career in robotics. You've actually opened our eyes. You have actually made us know that it's not all this theory supposed to be mental, it's supposed to be intentional, it's supposed to be something hands-on practice. Thank you, we appreciate you. Please, I don't know if anybody have any question for him. You can drop it in the chat or raise your hands. Any question?
Yes.
Do we have any question? You can drop it in the chat.
Finish.
No. Yeah.
Okay.
Finish.
Please mute yourself. Somebody is saying very educative, including myself in Chinese department. That's an associate professor from Nnamdi Azikiwe University, Dr. Lois Chinenye Okoye. RAS Nigeria is inclusive and has diversity. So at this point, I don't know whether Dr. Godwin Ozo is here. He is the pioneer chair of RAS Nigeria. I don't know whether he's still here. I can see him. Okay. But I can see somebody like Dr. Ezekiel Nnamere. Please, I want you to say one or two words to our speaker, our secretary, Nigeria section, the chair of PEARLS, Nigeria, Dr. Nnamere Aneke. You have the floor, sir.
All right. Thank you so much, my chair. And a very good morning to all of us on this call. I want to sincerely, on behalf of IEEE Nigerian section, to appreciate our guest speaker, Engineer Dr. Mbono, for this high impact lecture delivered this morning on building a career in robotics. So I must say that your lecture, for me, has been very impactful, and I believe our students on this call, they will go back and have a rethink of the way to go. So thank you so much for coming to deliver this lecture, and we'll plead with you that when next, maybe some other chapters may reach to you to also deliver this kind of lectures for them. We pray that when such call or message comes to you, please oblige us. Thank you so much for your time, sir.
Auntie?
Thank you
Thank
so
you
much.
so
Thank you
much.
so much, Doc.
Thank
Please,
you,
are
Dr.
we done?
Ezekiel.
So sorry for joining late, too.
There's some questions there, but they are from year one students. Well, one is asking, how does Arduino work? How does Arduino work? That one is something, a broad one. But I don't know whether you can give me 1 or 2 words how somebody can begin learning using Arduino.
Okay. You can see my screen. Can you see my screen now? My computer? I want to answer just in a very brief way, answer his that question. Can you see my screen now?
Yes.
So how does Arduino work? I will just pick an Arduino and show you how it works. I'm just launching Pro Tools this thing software. So I hope I've clicked that. Okay. So I pick an Arduino. I pick an Arduino hardware. Arduino. Arduino hardware. Okay, this is Arduino. Let's just pick one. So we pick this, and possibly I pick an LED. An LED. Okay. So I put them here, and that's that. So this is your Arduino, and this is your LED. I won't do the design now, but look at it. I want to control this LED. So this is the hardware now. I connect it here. And then through a resistor, normally it should be through a resistor, but let me forget about the resistor now. Let me just connect it to a power supply, which is, I just want to demonstrate something. Please don't connect 5 volts to your LED to burn it off. Now, this is Arduino. You are going to program it, a hex file, put a hex file here and program it, and this LED begins to function the way you want it. How do we do that? Look at your Arduino IDE. When you get your Arduino IDE and install it, you will have this kind of setup. Go to Files, Examples. Let's just pick basic example. Let's just pick this one, LED blink, something that will blink an LED. Let it open. It's opening already. So these are the programs that came with Arduino IDE. When you install your Arduino IDE, there are default programs, examples that came with it. You can start with that. And then what is that? What this program is doing is that is going to cause whatever that is connected to digital pin 13 to begin to blink on and off at interval of 1 second. So what do? I compile this program
and upload.
Where is it? So I compile it. After compiling it, I will look for the hex file. The hex file is like the hex file is not showing. The hex file didn't show. Hold on. You go to preferences if it doesn't show, and where is it again? I think that is probably because I'm online, but the stuff is I'm not seeing what I'm looking for. If it doesn't show, normally you come here. I think it's probably because I'm online. But then, if we are not online, what will happen is that you come here, copy the hex file that would show here, come back to your schematic design, open this, paste it here. Once you paste it here, and you click run, the system begins to respond the way you want it. If it doesn't work that way, you go back to your software, change it. So that is the way Arduino work principally. If it is you are now working with it physically, you follow the same process. You write your software. In this case now, after writing the software, you have to program the software with your cable, program it, connect it to your computer, program it, it begins to work. Thank you very much.
Thank you, Doc. Somebody asked a question. He says, thank you, sir, for such an eye-opening and impactful lecture. My question is, how best can you advise some of us that have stayed long in the field but would like to fall back to this robotic and automation line, considering the enormous study base? Maybe how can we cope with meeting up? That is Uncle Francis Oguleke is asking. Thank you, sir.
Okay. What is clear in my mind is if you have developed probably along a certain path, and then we want to go back to robotics, I think the answer I will give you, if you try to do self-development, it works fine. But try to get somebody that is already in the field. Let the person be your mentor. Let the person guide you. Let the person guide you. Just a minute. I'm coming. Sorry about that. I needed to control something. So you get somebody that is already in the field that knows how to go about it. And you begin so that the person will guide you on the step-by-step approach you are going to follow. I've already said you need to learn assembly language. After that, you do this. After that, you do that. That was during the lecture. But if you try to just go online and begin to study everything you see, I think you might get confused, and we don't really have all the time. You need some person that is already in the future you want to. So the person will tell you, do this, do this, do this. Then when you have problem, instead of sitting down to solve it for nights, the person will simply help you okay, is behaving this way, this is what you do, it will shorten your journey. There are other areas of my life that I needed to upgrade. I didn't want to make mistake about wasting too much time. I have to look around and get people in the field already that know what they're doing. They put me through, and then it's important that you know how to move, and then you begin to move. I don't know whether that helps you, but that's the answer that is clear in my mind now on how to build. Over to you, Doc. Is Dr. Chioma still there?
I don't think.
Probably her network went off. So what do we do? Someone else can, I don't know who is seconding her now. The person that read my profile citation, is the person still here?
Hello. Hello, I'm back.
Okay.
Sorry, the network took me off.
I know.
Thank you, everyone that is here. I was wondering whether Dr. Engineer Otubon, whether you're still on call, so you could do the closing remark. Engineer Otubon, I don't know whether you're still there. I can't see you. Dr. Ifeoma Sianuba, I want you to say something to our speaker, Dr. Ifeoma Sianuba.
All right, thank you very much. I especially tell the presenter, he did justice to all that. Yes, I could see some young minds inquiring, wanting to know everything in one day. Like he said, it's a gradual thing, a mentor to get there. So I want to sincerely thank you for doing justice to the topic. You really did that. You can see the young ones are inspired. They want to know more. That makes really opened their eyes to what's God and this particular sector. Thank you very much for the insightful presentation. Thank you for the illustrations and the video as well to add to what you have done. We are really very grateful. And like we always say, whenever we call upon you to come and do more, you will be there to deliver on the future topics that you'll be giving. Thank you very, very much. We appreciate your efforts, your concern, your preparations, and all that. We are very grateful. Thank you very much once again. Over to you, Dr. Chum.
Thank you so much, Dr. Ifeoma Sianuba from Uniport there. I want finally the head of Department of Chinese Language, Nnamdi Azikiwe University, Shizimi Wise, even though she's not from this background, but we believe in diversity, we believe in inclusion. She told me she would be at the event, and here she is. I want to ask her to do a closing remark. Dr. Chinemi, go ahead.
A wonderful opportunity.
We can't hear. We can't hear the doc. Can you hear him or her?
No. It's okay.
Speak on this your department better. Hear me now. Can you hear me?
Yes, you can.
Yes, we can hear you, ma'am.
Okay. Okay, sorry about that. I was saying thank you. A vote of thanks, very much grateful. Even though I'm not from your department, but you were able to carry me along. I couldn't even leave the system I was working with. I couldn't. I was captivated. You brought it to a layman's level where I was equally.
Thank you so much. We return all the glory to God for that impactful section. Thank you, everyone.
Thank you, everyone. We look forward to, we've gotten approved.
Department HOD. I say thank you. Don't like us. So over to you, Chairman. Doc, over to you.
Okay. Thank you, everyone. We look forward for more impactful events. We've gotten approval from Robotics and Automation Committee to invite distinguished lecturers from different regions to join us in our event. So we look forward for more insightful events, and then we will be inviting our distinguished lecturers in no more in any time soon. We will. Thank you so much for joining this call. I appreciate everyone that joined. Have a beautiful morning from wherever you are. Thank you. Thank you. God bless you.
Thank you, everyone. God bless you. Have a beautiful weekend.
Bye.
Bye.
Bye-bye.
Bye, everyone. Bye. Bye, Jen.
Bye.
Bye, Jen. Share.
Thank you. Thank
Bye,
you so much.
everyone.